All right, guys. Test coming up. Got a lot of reviews to work on. This one and the one that you have to turn into Schoology are the main ones for sure. I wanted to work through these so that you could figure out where you're going wrong if you're messing up. All right. So this, I'm gonna go through each question. Obviously you can fast forward to the parts that you need. But here we go. First section says if A is parallel to B, but C is not parallel to D. So A and B are the parallel lines. That would be the two green ones here are parallel. That means we are allowed to go left and right, left and right. Your transversal better touch two parallel lines. So let's say that you chose angle 2, right? Angle 2 is the one, yeah. Like, could I say 2 and 9 are equal, or sorry, 2 and 10 are equal? Well, look at our transversal there. Here's our transversal. Does that cross two parallel lines? Are these lines parallel? Did they say? No, they said A is parallel to B, but C is not parallel to D. So I know it looks close, but we cannot go by looks. I've stressed this so much. Hopefully we're getting to the point where we kind of understand that. So we cannot assume things are parallel just because they look like it. So that is not what we can do. What we can do is this way. So like for instance, if angle 2 here was 100 degrees, we would know that this is 100, we would know that this is 80, and we would know that this is 80. Because the transversal going this direction, that crosses two parallel lines, that means this is the same intersection. This would also be 100, 100, 80, and 80. All right, so name all the angles congruent to 2. Well, that would be angle 5 because it's vertical. That would be angle 4 corresponding. And that would be angle 7 alternate interior. So 5, 4, and 7. All right, I'm going to go a little quicker through the other ones. The next one, it's just like the one we just did, except for this time it's C and D that are parallel. So now it's C is parallel to D. So yes, now we can go up and down. Now it's those two intersections that are the same. So 2 and 5 obviously still equal vertical angles, but now 10 and 13 are the same size. So it's going to be 5, 10, and 13 for this one, right? If you go this way, now you're not crossing parallel lines. You have to cross the lines they tell you are parallel. All right. On the next one, now we have more. We have A is parallel to B. Nice. Where's A? A is parallel to B. And C is parallel to D. Okay. Woo! Now we can go every direction. So like we know that 2 and 5 are the same. We can go down here to this parallel line. We can go over here because of these parallel. We can go any direction now. If I go this way, I cross the two greens. If I go this way, I cross the two reds. Am I crossing two parallel lines no matter what? Yes, I am. All those red angles are the same size. So name angles supplementary to 1. Okay, let's look at angle 1. Here's angle 1. Well, which ones are the same size as 1? 6, 9, 14. All of these are the same size as 1. And there's only two choices. You are either equal or supplementary. So if you're not equal, you're supplementary. That means 2 and 5 are supplementary. Look at those. 2 and 5 are both linear pairs. That means 10 and 13 are both supplementary. That means 4 and 7 are supplementary. That means 12 and 15 are supplementary. All those red ones will be supplementary, right? If this is 50 degrees, all of these are 50 degrees. That means all the other ones are 130. All the other ones are 130. So yeah, they're all supplementary. Okay, next one. This one is the measure of angle 6 equals 38 degrees. A is parallel to B. All right, so right away, if that's 38, I know this is 38, I know this is 38, I know this is 38. I know all the other ones are 142. Boom. That's because this transversal, the one going left and right, is the one that crosses the two parallel lines. I have to cross the green lines. And C is parallel to D. Oh, I didn't keep reading. So C and D are also parallel. Well, that's fun. That means all of the intersections are 38s, 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 142, 142, all over. So how big is angle 12? Well, it's either 38 or 142. In this case, it's 142. How big is angle 4? And it is also 142. There you go. Okay. Okay. I like it. And then we have another one here. It says angle 2 is 115. Love it. Hi, 115. That means this is 115. 65 and 65. I don't need parallel lines to know that. Those are just vertical and linear pairs. Angle 16 is 80 degrees. Oh. 80, 80, 100, 100. I don't need parallel lines for that. And A is parallel to B this time. So just A and B are parallel. So what direction are we allowed to go? We're allowed to cross the parallel lines. 65, 65, 115, 115. Over here, 100, 100, 80, and 80. We can go this direction with our properties. So angle 14 would be 80, and angle 7 would be 115. Oops. Got it. Okay, moving on. Find the values of x and y's. Guys, got to use your parallel lines. That's going to be what we mess up on. That's what I don't want you messing up on. Parallel lines, highlight them if you need to. Use the angles you know. You should not be looking at x and y. Stop it. Stop it. 63 we know. Does it touch a parallel line? Then use it. Start, turn, turn. 63. Didn't hesitate. 61. Turn, turn. Ooh. I'm going to keep going. Make the letter F corresponding. Nice. So x equals 61, y equals 63. That was just all parallel lines. Over here, parallel lines. They're left and right. So can I say this? Is this true? 2x plus 86 equals 180. Is that true? Can I use those two? Can I use those two? Can I? Can I? Can I? How many parallel lines are there? How many? Tell me. Oh, Mr. Balin, they look parallel. Does it matter if they look parallel? Does that matter? No, it doesn't. They told us left and right are parallel. That's it. So we can't do that. Here's what we can do. We can do this way. Those two angles are going to be same side interior. Those are going to add up to 180. Yes. So 4y equals 94. So y equals, oh dear, 47 halves. Does that sound right? 94. Yes. Okay. And then the other pair is this way. Those use parallel lines, right? If I circle those, have I touched two parallel lines? Yes. That means 2x plus 88 equals 180. So 2x equals 92. So x equals 46. There's my answers. Parallel lines, that's the key. Oh, look at this picture. You loving it? You loving it? I'm loving it. So let's talk about these parallel lines. Boom, boom. Already, what do you know about those two spots? Those are same side exterior. They're going to add up to 180. Don't hesitate. 2x plus x equals 180. 3x equals 180. X equals 60. Got it. We have other parallel lines as well. Parallel blue and blue. What are those two spots? Oh, let's see. Trace, trace. That's the letter F. We know that those are going to be equal. Well, if x is 60, isn't this corner going to be 60? So 3y plus 6 has to be 60. So 3y has to equal 54. So y has to equal 54 divided by 3, 18. There we go. That's all parallel line stuff. I know we can do this. I believe in you. Oh, love it. More. Parallel. Let's go. Parallel. Oh, man. Oh, I already see. So here's what we got to do. I've told you this a million times. How many times? A million. Focus on the angles you have. I know the 50. Vertical, going to be 50. Is there anything else I can do? I need you to look at this so hard. Use your eyeballs and look at this, please. That's right. It touches the parallel line, so we're going to trace it. Boom. There we go. That's got to be 50. That's got to be 50. Love it. So I see some stuff I can do here. I have 70. Look at these three angles. Those are a triangle. So we have 70 plus 50 plus 4y have to be 180. So 4y has to equal 60. So y has to equal 15. Got it. If y is 15, then we know that this corner is 60. So 60, 50, this has to be 70. I know what you're thinking. Mr. Balin, didn't you yell that? Yep, you could have done it like this. Those are corresponding, so you could have known it that way, letter F. But we know that 3x plus 10 has to equal 70. No matter how you slice it, 3x plus 10 equals 70. So you get 3x is 20, not 20, 3x is 60. X would then be 20. Perfect, loving it. Keep the ball rolling. Keep rolling. All right, why? Go. All right, parallel lines. Whoop, got it. And whoop, got it. Look at those. Look at those. I know you already see it. It's a beautiful thing. All right, I'm going to go to this 48 that I know because it touches a parallel line. And I'm going to turn, So I know that 3x equals 48. So I know that x has to equal 16. Okay. Well, I'm looking at the other number they gave us. Right now, right here, so many of you guys would sit here stuck. Look at the other number they gave us. There's nothing else I can do with that 48. 48's done. But I gave you 64. Look at the 64. It touches a parallel line. Trace it. Follow the transversal. When do you turn again? Parallel line. That's going to be 64. Those are corresponding angles. They use the parallel lines. If all of the rest of this was gone, would you see it better? They're corresponding. All right. So what does that mean? That means these have to add up to 180. So we can write that equation. We know that 2y plus 14 plus 64 has to be 180. So 2y, that would be 60, 78, that'd be 102. So we know that y equals 51. Oh, gorgeous. Okay. Use the diagram. Oh, I don't see any parallel lines. That's okay. I love triangles too. Here's a property you have to know. So they're saying measure of angle 4, that's this guy, is equal to what plus what? In this picture, what would angle 4 equal? We talked about this rule before. Remote plus remote equals the exterior angle. This is an exterior angle. We have 1, 2, 3 interior angles. Which ones are the remote interior? Remember, R means remote interior. Which ones are the remote interior angles? It's 1 and 2. 3 and 4 are adjacent. You can't be remote and adjacent. Remote means not touching. Adjacent means touching. So remote interior angles don't touch the angle. It's got to be 1 and 2. So if this was 50 and this is 60, then this would be 110. Remote plus remote equals E. You need to know that. All right. So R plus R equals E. So angle 4 would equal angle 1 plus angle 2. What if the measure of angle 1 is 37? Angle 5 is 101. What would be angle 3? Well, we know that 37, we're looking for 3, I'm going to call it X, plus angle 3 has to equal 101. That is remote plus remote equals E. This is the exterior angle over there. So that would have to be, what, 100 minus 37, 63? No, sorry, 101. I was like, what happened? Should be 101. My bad. So 64. Got it. Boom, shakalaka. All right. How about the next one? If angle 6, I'm not going to fill everything out, but we got 6. Doop. We've got angle 1. Doop. And we've got angle 3. Boop. Oh, same idea, right? Remote plus remote equals E. We know that 1 plus 3 has to equal 6. So let's write it out. 1, 5x minus 19. Plus 3, 7 times x minus 12 has to equal 6. 6x plus 23. R plus R equals E. Clean this up. This would be 5x minus 19. That'd be 7x. That'd be 70. Be 84. This would equal 6x plus 23. That would get me 12x, 6x. That would give me negative 84, negative 103. So it'd be 126. Divide by 2 be 63. Divide by 3 would be 21. So x equals 21. Plug that in. 6 times 21. Or sorry, don't want to get ahead of myself. Angle 6, right? They said find the measure of angle 5. What do you know about angle 6 and angle 5? They're the same size. So plug that in. 6 times 21 plus 23. That would be what? 126 plus 23, 149. I hope I'm right. I'm going kind of quick. If I'm messing up on the multiplication and stuff like that, I'm really sorry. I think I got it right, but I am going fast. Write the equation of the line in slope-intercept form for the following. The line contains this point. It must be perpendicular to this one. Okay. So remember that parallel slopes are equal and perpendicular slopes are opposite reciprocals. So we talked about that before. I'm not going to go over that more right now, but this is perpendicular. I need the opposite reciprocal. So let's get the slope first. So the slope is, we look at the y values, negative 2 to 7 is plus 9. 3 to 5 is plus 2. That slope is positive 9 halves. I need the perpendicular slope, negative 2 ninths. Let's make sure I got that right. Plus 9, plus 2, y's over x's. Flip it, negative 2 ninths. Perfect. Okay. So that's negative 2 ninths. And I got to go through this point. So I told you guys, y equals mx plus b. This is the point we have to use. That's the point we got to go through. So that's my x and my y. So I'm going to plug in 1 for y. Negative 2 ninths has to be my slope. X needs to be 6 plus b. Clean this up. 6 and 9, that's 2/3. So 1 equals negative 4/3 plus b. Add 4/3 over. That would be 7/3. So y equals negative 2 ninths x plus 7/3. All right, we got a proof here. Look at this given. I love it. Oh, this is nice. All the given stuff. Guys, we talked about this before. If I told you x equals 7 and y equals 7, what does that mean? That means that x equals y. They're the same size. They're the same value. If two things equal the same thing, right? If two things, x and y, equal the same thing, 7, that means they're equal to each other. If this equals 180 and this equals 180, that means these are equal to each other. So the measure of angle 1 plus the measure of angle 4 has to equal the measure of angle 1 plus the measure of angle 5. That is a substitution. I'm taking the 180 out and I'm plugging this in. That's what I'm doing mathematically. It's a substitution. Okay, now look at this. They both have an angle 1, right? Like if I said x plus 7 equals y plus 7, right? Wouldn't you subtract 7 and it would cancel out on both sides? Yeah. That's basically what's going on here. The angle 1 is going to cancel out on both sides. Sorry, there we go. So what happens when we subtract angle 1? We get angle 4 and we get angle 5. That's a subtraction. So now we know 4 and 5 are equal. So let's go look in the picture. Here's 4 and here's 5. We just said they're equal. We didn't even look at the picture till just now, by the way. A lot of you guys look at the picture like, oh, they're equal, alternate interior angles. That's not how you know they're equal. Remember, alternate interior angles require parallel lines. They didn't tell us any lines were parallel. So what do we know now, though? If they're equal, does that make the lines parallel? Yes, it does. So we now know that YZ is parallel to VU. How do we know it? That's the alternate interior angles converse. Remember, parallel lines cause alternate interior angles to be equal. That's the normal definition. That's the normal theorem. Well, we just knew that alternate interior angles were equal. That caused the parallel lines. That's the converse. That's what happened. We knew they were equal because of the equation we just cleaned up, right? And once we knew that they were equal, that means the lines are parallel. That's the converse. Let's go. All right, angle 2 is congruent to angle 4. AB is parallel to CD. They marked that for us, but I'm going to bolden it up. That makes me super happy. Okay, those are parallel. Prove that EA is an angle bisector. Where's EA? EA, that's this guy. Okay. Well, I can do that. Can you do that? Let's do that. So if I'm trying to prove that's an angle bisector, I need to ask myself, well, what is an angle bisector? Cuts an angle in half. So what would make this an angle bisector if the angle was cut in half? In other words, if 1 and 3 were equal. So our goal is to prove that angle 1 and 3 are the same size. That's the evidence we need to prove that that's an angle bisector. All right, let's go for it. So we have all the given. What do we know? So they gave us 4 and 2. We're looking for 3 and 1. Are there connections from 4 and 2 over to 3 and 1? The answer is yes. I'm not going to spend too much time on it. But angle 4, parallel line, I trace it. I know it's the same as 3. So I can say angle 4 is congruent to angle 3. That is those are alternate interior angles. That's the alternate interior angle theorem. The other angle that I have is angle 2. They tell us angle 2. We'll trace it. Same thing. Parallel lines. 2 and 1 are going to be equal. They make the letter F. So angle 2 is congruent to angle 1. And that is the corresponding angle theorem, right? 2 and 1 are corresponding angles. They use the parallel lines. They're corresponding. So let's see this progression. This is totally pretend, but let's say that this was 50 degrees. I'm just making that up. Angle 4 would then be 50 because they said they're the same. Well, if angle 4 is 50, that means 3 is 50, right? If 4 is 50, 4 is 50, then 3 is 50. And then we said angle 2 is 50. Well, if angle 2 is 50, that means angle 1 is 50. So what have we established in our proof about angles 1, 2, 3, and 4? They're all the same sides. But which ones do we need to say? I can't hear you. We need to say angles 1 and 3. Remember, that's what we said at the beginning? That if angle 1 and angle 3 are congruent, guys, this is technically a transitive situation, but I told you we're doing substitution this year. So don't call it transitive, it's substitution. If you know how transitive works, you can use that, but we did not go over those differences this year. But we're going to say that those are congruent. Basically, it's a long-range substitution. So now we can say that EA is an angle bisector, and that's just the definition of angle bisector. Boom, crushed it. Moving on. Oh, this is great. Love it. Quadrilateral ABCD has those coordinates. Write an equation through F parallel to AB. They gave us the graph. I don't actually need the graph, but they're saying label it as G. Okay, well, let's go ahead and just draw it out. They seem to want us to, so I'm going to. So I'm going to get my points on here. -1, comma, -4. -1, 1, 2, 3, 4. That's A. -2, comma, 1, B. So that's almost vertical. -4, -2, C. And -3, -7. 1, 2, 3, 4, 5, 6, 7. -3, -7, that's D. Okay. Write the equation through F. 6, comma, 5. Well, hello, F. So 6, comma, 1, 2, 3, 4, 5. 6, comma, 5. There's F. Parallel to AB. So, like if we were to draw AB, it would look like this. So we want that slope. We need the slope of AB, right? If it's on the graph, you could just count it. That's 1, 2, 3, 1, 2. So we know the slope is 3/2. Okay. So A to B. Wait, did I do this wrong? That's D. All right, sorry, fam. Let's start it over. Let's go back in time. Sorry, A to B, parallel to AB. So I need a line that goes from A to B this way. That's a little different. So something like that. So that'd be 1, 2, 3, 4, 5, 1. So that's up 5, left 1. That's a slope of -5. So you can get the slope any way you want, but from A to B, that slope is -5. I don't care how you do it. I promise that's what you'll get. So I know the slope, and I know I got to use this point. So let's do it. We could do it on the graph, but I don't want to. So we're going to say y equals mx plus b. We're going to plug in 5, right? This is my x and my y. Plug in 5 for y. Plug in -5 for m. Plug in 6 for x plus b. So 5 equals -30 plus b. So b equals 35. So y equals -5x plus 35. It says label its x-intercept G. Okay, well, if I apply, the slope is -5, right? So let's just do that. 1, 2, 3, 4, 5. Oh, there's the x-intercept right there. So there's your parallel line. There's the x-intercept. Ah, why are you doing magnifying? Oh, dear, I messed that up. I have no idea why it did that. Why is it doing that? It's never done that before. Okay, something like that. That feels really wrong. Why does it look bad? That looks bad. That looks better. It's because my dot's in a weird place. Okay. But if you don't know that on the x-intercept, we haven't really talked about this very much, but the x-intercept, that means that y has to be 0. So could you just plug in 0 for y? Change colors up a little bit. So 0 would equal negative 5x plus 35. So 5x equals 35, x equals 7. Is that what we got? Yeah. 1, 2, 3, 4, 5, 6, 7. Yeah. So the x-intercept is g. Okay. Okay. Show that FG is parallel to AB. Okay. Well, m equals, so we know that AB has an m of negative 5. We know that FG, same thing. Okay. Oh, we didn't actually show it, so let's show it real quick. So we have F at 6, 5. We have G at 7, 0. So let's do that real quick. The slope here would be 5 to 0, that's minus 5. 6 to 7, that's plus 1. That's a slope of negative 5. Now we've showed it. Okay, okay. Draw a line AG. What do you know about angle BA? Ooh, this is fun. So let's draw a line AG, just like they said. What do you know about angle BAG? That's this angle right here. Well, we know that the slope of AB is negative 5. Let me get the slope of AG. So what are my points there? For A, it's negative 4, negative 1. Nope, got that backwards. Negative 1, negative 4. And G, we just said, is 7, 0. So what is that slope? Negative 4 to 0, that's plus 4. Negative 1 to 7, that's plus 8. That's positive 1/2. So draw a line AG. A is at negative 1, negative 4. G is at 7, 0. Plus 4, plus 8. So what do we know about that angle? I'm not entirely sure what we know about that angle. Okay, where's angle FGA? I'm missing something here. Let's go. Oh, here's angle FGA. Oh, what do we know about these two angles? Here I am doing slopes. I'm a bozo. These blue lines are parallel. What do we know about those? See, these questions, you got to read the whole thing. I just stopped at BAG. I was like, well, let me get the slope, and I don't know what I was thinking. That's bad behavior. Got to read the whole question. Both those angles, those are same side interior, right? Those are supplementary. They are supplementary. We know that they're supplementary, right? Parallel lines, those are same side interior. Boom, shakalaka. Woo! That was fun. All right, guys. Hopefully that helped.